Hello, friends. Thank you for joining yet another session on cryptography and digital signatures. So, in my previous two sessions, we saw some basics on cryptography, like creating digital keys, what are symmetric keys, asymmetric keys, and how the keys are packaged into certificates. We saw two types of certificates, X59 and GPG. And in my second session, we saw how to create digital signatures, what is the procedure followed, what is hashing, what is encryption, and how a combination of these, how both of these are used to generate digital signatures. And then we saw some examples on, we created some digital signatures and verified them. Um, saw some tools on that. This is my third session where we'll be looking at how digital signature is packaged along with the binary. So we'll see some different types of files and how signatures are packaged in those files. Now, now, a digital signature can be packaged in many ways. So we look at four of those. So one is where a signature, the whole file gets enveloped inside a signature. There's a second way is where you append a signature onto a file at the bottom of file at the end of file. And in the third option, we insert a signature somewhere inside the header of the file. And in the fourth option, what we are seeing, we will see how to generate a detached signature. Now, envelope signature. So typically this is used in for signing text files for or emails. We use a SMIME header approach for that. Now, when you are signing a file in a envelope signature format, so at the top there will be a so the whole signature envelope is generated and the file is embedded inside the envelope. So these are the commands to generate a signature: OpenSSL SMI minus sign minus in plain text. So let me run this command on my console and let's see what happens. We go to console. So this is my plain text which I'm going to sign. I've copied all commands here so that it's easy to run them. Right. So what I've done here is OpenSSL sign input will be my plain text and the signer key pk.cert. So what is pk.cert and pk.key? To get more details on that, you'll have to go back and look at my first presentation, which explains these keys. Now I'm signing with my public key private key pk.key, and my public key is there in pk.cert, and the signature is generated in signed plain text. There's a file where a signature is generated. So let's see what is there in this file with more. All right, so a new envelope is added, a header is added, and then my actual file data is embedded inside it, followed by the signature and the public key of the signer. So this is my data envelope. So see, in the beginning we have the header, and then I have my actual file contents embedded, followed by the whole signature and public key, which is similar to the format what we discussed here. Now to verify this, can quickly check verify this. OpenSSL SMI minus verify. My input will be signed plain text minus signer, I think. Okay. Yeah. So this is all I need to give. All right, now it's complaining that my certificate is self-signed. I need to have my certificate. Typically, the keys are signed by a sub CA, and the sub CA itself gets signed by the root CA. But since these are my test keys, so I'm getting this error that my keys are self-signed. So what I do is I give minus no verify to ask OpenSSL not to verify my certificate chain, not to verify the chain of my key pk.cert. So when I do this, I get back my data and my signature verification is successful. So that's how you generate a enveloped signature with the file contents embedded inside the envelope. The first type what we saw here. Moving on to the second type. Now these signatures are there for binary files like EFI files or PECOF files. The signatures are appended to the bottom of the file. So this approach is also followed for ELF files in Linux world, or EFI files, PCOF files, grub files. So in these kind of files, the signatures are appended at the bottom of the file. If you look at the diagram, so typically there's a P header, um, and which has a pointer to certificate table. So at the end of the file, all my signatures get appended. So a file can have more than one signature. So in that case, all the signatures get appended one below the other. Now there are various tools to so OpenSSL is a common tool to sign various kinds of files, but there are some specific types of files like the PECOF files where you don't generate signature for the whole file itself, but you look at the segments. Now, EFI file or ELF file will have a whole lot of segments like the text segment, data segment, um, um, RO data, and a bunch of things. So you cannot generate a hash for the whole file as such. I mean, it doesn't make sense. So what these tools do is they generate hash for each of those segments and then generate merged hash of all the hashes. So SBSign is a tool which is available open source, which I've used to sign EFI files. So I'll quickly show you. So I have a hello world unsigned file here. All right. So when I sign it with SBSign, I have the command saved here already. Let me just copy and paste it. Okay. So what I've done here is SBSign. SBSign is a tool to sign EFI files or PECOF files. It takes input my private key, my public cert, output is a signed EFI file, and input is unsigned EFI file. So I just run this command and this is what I get. So let me see a diff of my signed versus unsigned file. Diff minus y xxd, give this input to xxd, hello world unsigned, another input is xxd, hello world signed. So what I'm doing here, xxd is a tool to do a binary dump of the file. So these are all binary files. So I do a hex dump of my binary file, provide two inputs to diff. One is a hex dump of unsigned file, and second is a hex dump of my signed file. Pipe with color diff. So this will generate a diff of these two files basically. And if I see, you see this, the content of both the files. The file on the left side is my unsigned file, and the file on the right side is my signed file. And as you can see, the signature is appended at the bottom of this file. Okay, and somewhere in the header there should be a pointer pointing to this signature. We can verify that as well. Yep, you see some changes here. So my header has been changed to point to a signature field here. So how do I verify these signatures? There's another tool called SB Verify. SB Verify minus cert. It just needs the public key. Signed. Oh, there's something wrong. Let me see the command. Minus cert pk dot cert hello world signed. That's right. Okay, minus cert. Yeah, verification is successful. All right. So this is the tool for appending signatures to end of binary, and this tool works on EFI or PECOP files. So similar to this, there are ELF files as well, and I think there's a tool called sign-tool which generates signatures for ELF files. It works on the same mechanism. It generates signatures for various segments, and then um, generates hash for various segments, and then ultimately signs those hash to form a signature, which is then appended to end of the file. Now, ELF files are typically signed while booting the for the purpose of kernel. Kernel has loadable modules called KLMs, kernel loadable modules. Now, the kernel loadable modules typically should be signed to have a secure boot verification in the boot path. So we'll see those details in my secure boot presentation. All right, proceeding further. So we saw signature enveloped, signature appended to end of file. Now there are cases where the signature could be inserted in the beginning or somewhere in the middle of the file. So these are the cases, for example, RPMs. So in case of RPM, a signature is inserted. So in an RPM, typically there is a RPM identifier or a lead which contains some sort of a magic which is used by tools to figure out what type of file it is. So after the magic, a signature field exists, which is optional, followed by the RPM header. Now, to sign an RPM, you simply call RPM minus minus add sign and the RPM to sign. And to verify one, you call RPM minus KV and the file to verify. Now to sign, before signing an RPM, you need to generate a GPG key and add it to your GPG database. So let me show you what keys I have. GPG minus minus list keys. So let me use this Acme Corporation key, which I've created as test key in my previous sessions. I'll use this to sign. Okay, I might not have created this. Anyways, I'll use this Acme Corporation key to sign my RPM. So the way you sign RPM is, let me see. Yeah, I have unsigned hello.rpm. So we'll just first check the signature of this rpm minus kv unsigned hello.rpm. So there is a hash and there's a hash. There's no signature. It's just there. It just has a hash. So we're going to sign this now. rpm minus minus define gpg name. Okay, this is the command I need to give. Okay, unsigned to temp.rpm. Let me try signing. So rpm minus kv temp.rpm rpm is the file which I'll use now. This file is unsigned right now. As you can see, there's a SHA header, SHA hash, and a SHA hash only. Now I'm using rpm define the name of the key to use sign, which is be Acme Corp, minus minus add sign. The file I'm going to sign is temp.rpm. Okay, it'll ask for a passphrase. You don't have to, I haven't given any passphrase, so I just hit enter. Now my temp.rpm is signed. rpm minus kv. Let me verify temp.rpm. Yeah, see, signature. Okay. Now it's giving signature okay because I've already added the key for verifying this RPM in my RPM database. So that is nothing to worry unless you're digging deep into signing RPMs. Anyways, the gist of what I wanted to show is you sign an RPM this way and then you verify the signature here. Now, if you dump the RPM content itself, you can see that the signature part is the signature is embedded somewhere in the header of the RPM. All right. So the next type of file is detached signatures. For now, detached signatures can be used for any type of file. It could be ELF, PCOF, data, XML, PDFs, text, whatever. Now, so there are tools to generate detached signatures. I have some commands here which can be used to generate a detached signature. Let me run them on the console. All right. So this is a command to generate detached signatures. So what I have done here is OpenSSL sign binary file. My input is of type binary. I've given it as a binary, but that's okay. So my actual input is plain text file. I'm using public key pk.cert and my private key pk.key. Out form is dir and my signature will be copied into file.p7b. So this generates a detached signature. All right. Now I have my actual file here, plain text, and I have my signature file.p7b. This is a binary file xxt. Okay. So file.p7b is my signature, detached signature. Now to verify this, I run this command. All right. So what I've done here, OpenSSL verify binary. File type is binary. Inform is dir because I generated a dir file here. In file is p7b. The signature in file is a file containing signature, and I'm trying to verify the signature for the content of plain text file. Okay. Now I've given minus no verify here because I don't want this tool to verify the search chain. Remember, sometime back we saw that we saw the problem that the tool was trying to verify the search chain and it would say this is a CS cert. So to avoid that problem, I'm giving minus no verify. So what it does is it verifies the signature, and when things are fine, it dumps the content. All right. So if you want, I can modify something in this file. Maybe add a dot and see if verification happens properly. Yeah, there's a verification failure. All right. So that was a detached signature. So to summarize, signatures can be either enveloped in a data file, or you can have signature appended to the bottom of file in case, which happens in case of ELF, PECOF, EFI files, or you can have a signature embedded inside a file, which can happen in case of RPM files, or you can have a detached signature. Detached signature is typically used in case of, say, signing the init during Linux boot up. All right, so that's all I had, folks. Thank you for watching this video. As always, I'd be glad to hear your comments, suggestions, and if there's anything, my LinkedIn profile is given in the description of this video. You can get in touch with me or that as well. All right, thank you.